Alright, so in this video, we want to review a little bit of the concepts that we were covering for mathematics of finance. So the two main concepts that we were studying was the difference between simple interest and compounded interest, and how simple interest grows linearly compared to compounded interest that grows exponentially. Alright, so this is the formula for compounded interest, and we want to see what does it look like when we do compounded yearly. Alright, so when something is compounded yearly, we have the amount after n number of years is equal to P, where P is the principal amount. All right, and times 1 plus R. R is the yearly rate. All right, this amount is growing, and N is the number of years. All right, in this case, 1 year, after 2 years, after 3 years, and so on. All right, but when something is compounded yearly, it can also be compounded monthly. All right, so this is the formula for something that is compounded monthly. Well, it still follows compounding interest, so the formula is the same, but some numbers need to change, because now we don't have a compounded period per year. We have 12 compounded periods per year. All right, so this formula needs to change. This R is no longer going to be the rate for the year, but rather the rate for each compounding period. All right, so the rate per month. All right, this N is no longer going to be the number of years, because we don't have 1 year, 2 years. We have 12 months, 24 months, and so on. All right, so we modified this one. Let's see, how can we modify this one? So the amount, all right, after n number of months, all right, years, is going to be equal to P. Well, the principal is not going to be affected. 1 plus, well, R is going to be affected, all right, because R was the rate for the entire year. All right, we want to get the rate per compounding period. All right, so since there's 12 periods in a year, we need to take R and divide it by how many compounding periods. There are k compounding periods in a year, and it's no longer to the n power, but rather times how many compounding periods per year times t. All right, and t is the number of years that are passing. All right, so in total, this gives me the number of compounded periods. All right, and this is the rate per compounding period. All right, so let's see, let's do an example where we do this one. All right, so wait, let's finish this one. A to the n is equal to P times 1 plus, we'll take the rate divided by 12, all right, times 12 periods times t. All right, in this case. All right, so let's do a problem. All right, so here we have Mr. Pythagoras invested $5,500 6 years ago, earning 7% compounded quarterly. All right, what will the investment be worth in 4 more years from now? All right, so here it's important to understand that they want compounding. All right, interest. All right, so we need to use the beautiful formula. A to n is equal to the principal to 1 plus R over K times KT. All right, and K was the number of compounding periods. All right, in this case, they're saying that we have quarterly. All right, that means 4. All right, so AN is equal to the principal times 1 plus the rate divided by 4 times 4t. All right, so let's see, what does this become? Principal 5,500. All right, so it's equal to 5,500 times 1 plus, well, what is the rate? The rate is 7%. All right, 7% in decimal is 0.07. all right, let's divide that by 4. All right, so what does this become now? e to the n is equal to 5500. Oh, I should have finished this one. 1 plus 0.07 divided by 4 to the 4 times n, right, or t, whatever number of years. All right, in this case, so let's see, if he invested this one 6 years ago, let's see how much it's worth now. All right, so let's do this one to the 6. All right, so and so 6 years after, all right, of the initial investment, 5500 times 1 plus 0.07 divided by 4 to the 4 times 6 would be 24. All right, and if you use a calculator, all right, you end up with $8,340. Well, that is not bad at all. All right, if you put in $5,500 for completely forget about it and you get 7% compounded quarterly, that's the meaning of letting your money work for you. Alrighty, but that is how much it's worth right now. All right, if we invested it 6 years ago. All right, so if they want us to tell them how much would it be worth in 4 more years from now, well, that would be a total of 10 years. All right, so if there are 4 compounding periods per year, 4 times 10 is 40. All right, so the money is going to be compounding for 40 periods total. All right, so let's see, let's find the amount after 10 years. All right, so this is equal to 5500, all right, times 1 plus, well, what is the rate per compounding period? All right, well, if we know that the rate for the year was 7% divided by 4, all right, and then 4 compounding periods per year times 10 years. All right, so the amount after 10 years is equal to you give me that value.